Okay, so now we are going to look at the equation of independent t-test. So for independent t-test, we are going to look at the formula that is used in calculating the independent t-test. And remember that independent test is trying to compare the mean of two different groups, that is two independent groups. So here we have x1 bar and x2 bar. The x1 bar and x2 bar represent the means of two different groups. And then we have n1, which is the number of sample of group 1, and then we have n2, the number of samples in group 2. Then the SS is the sum of squares, the sum of the squares. So now we are going to look at some example. So now, suppose we have to compare the mean value of two groups, one with 7 subjects and the other with 5 subjects. So now let's look at the subject. So we have case 1 to 7. So group 1 have 1, 2, 3, 4, 5, 6, 7. So we have seven subjects. And then for the group 2, we have 5 subjects. Then we now take the mean of group 1. And how do you take the mean of group 1? You add 78 plus 82 plus 87 plus 65 plus 75 plus 82 plus 71 divided by 7. And that is how 77.14 of 10. And then for the group 2, we also did the same thing. We add all these values, which is 87 plus 92 plus 86 plus 95 plus 73. Then we divide it by 5. We are going to get 86.60. So now we also go ahead and get the sum of the squares of the two groups. And the sum of the squares of the two groups is 620.06. So it is 332.86 plus, then for the group 2 we have 285.20. Then we now divide it with the number of sample, and then we have this. So therefore at the end we have t is equal to minus 0.44. And remember, for the independent or between the two groups, we need to get the degree of freedom. And how did we calculate the degree of freedom? We calculate the degree of freedom by adding the number of samples for all the groups, and we subtract it with 2. And that is why we now take the absolute value of this, which is this. And then now for the 0.05 probability level, then now we are going to get the critical t-score. And how did we get the critical t-score? Is okay. Now, based on the degree of freedom, we have 7 plus 5 sample, making 12. So now 12 minus 2, then we have 10. So if we are using 95% confidence interval, it means that we are going to use degree of freedom of 10 under 0.05, and that is how we are going to obtain a value of 2.228. And then let's go to the table and see how this 2.228 is being obtained. Okay, then this is the table, and now where is the degree? Where do we have 10 in this table? We have our 10 here, and then it's under 0.05 probability. So now we come directly here and take our value as 2.228. So now, after this, we are now going to look at how we are going to impute that value. So since the calculated t-score is less than the critical t-score, then the results are not significant at the 0.555. So you see, of course, if you now do the calculation, because after when you plot your normal distribution curve, when you plot your normal distribution curve like this is your negative critical t-value, and this is the positive critical value. So for the positive critical value, for the negative critical t-value, we have 2 points minus 2.228. And then for the positive critical t-value, we have minus 2 points. So, but look, based on the calculation, you'll see that the calculated t-value is less than that of the critical t-score. Therefore, it falls within the acceptance region. So therefore, it means that the hypothesis or the null hypothesis will be accepted. Thereby, the alternative hypothesis will be rejected because the calculated t-value is less than the critical t-score. Okay. Thank you for listening.